Okay guys, in this video we are going to focus on converting numbers from hexadecimal system to numbers in decimal system. Numbers in hexadecimal system are said to be number in base 16, while numbers in decimal system are said to be numbers in base 10. So how can we work with the conversion? What are the process? Let's begin with an example. So how can I convert 3,421, that is in base 16, to number in base 10? So the first thing we are going to consider doing is to transform the hexadecimal number with the power of its base. So what does that mean? It means we need to expand each of the digits that makes up the hexadecimal number by the base. However, we need to be adding the results together. So I'm going to take the first digit to the left and multiply it with the base 16. So since I'm to add it to the next one, so I'm going to add the addition sign. Then 4 times 16. So I'm going to continue this pattern until I end the digits. So that's 2 times 16. And finally, 1 times 16. So for the second step, I will need to assign an index to the base, starting from the right hand side. However, the index will be starting from 0 as well. So the base I'm having first towards the right hand side is 6. So I'm going to assign index 0 to it. This index will begin to be increasing as you are moving towards the left. So that's 1, 2, and 3. And that's all. So you're good to go at this point. All you need to do is just to simplify. So right now, what is the value of 16 raised to the power of 3? So for a quick and easy result, I'm just going to type that into my calculator. And I tend to have 4,096. So I'm going to add that to 4 times 16 squared. What could that be? So that's 256. So I'm going to write that and add that to 2 times 16 to the power of 1 will result in 16. I believe you know that. Anything raised to the power of 1 is still that thing. But for this case, the case is different. 16 raised to the power of 0 will result in 1. Anything raised to the power of 1 is that thing. So finally, I'm just going to multiply 3 times 4,096. That results in 12,288. So I'm adding that to 4 times 256. So that results in 1,024. And 2 times 16 is 32. And 1 times 1 is 1. So right now I can add my results up. So I'm adding that to 32 to 1. And that results in 13,345. And this is our final answer for this problem. Hopefully, you understand the process and the pattern. Let's consider more examples for easy understanding. If you haven't subscribed to my channel, pause the video and go and subscribe to my channel now, as that will help me to reach a lot more audience. If you are finding this content interesting and helpful, consider hitting the like button to help YouTube know that this video is liked so they can recommend it to many viewers out there. Number 2, convert B4CD in base 16 to number in base 10. Pause the video and consider checking this question out. You might be wondering, what is the meaning of B, C, and D? Now, I must disclose to you, numbers that has to mix up hexadecimal numbers can be digits from 1, even including 0, all the way to 15, but not up to 16. For any number in a particular base, the digits that ask to mix up that number must not be up to the base. However, we don't write, okay, let me use just a parenthesis. We don't write digits that is more than 9 as it is in decimal number. When we are dealing with hexadecimal number, we represent them with letters. So assuming I wanted to write all the digits that makes up hexadecimal number, I'm going to start from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 16 must not be there because the digits must not be up to 16. However, these digits starting from 10 to 16, we can't write them that way because they will be considered to be a decimal number. However, we are dealing with hexadecimal number. So how can we express them? Then that is when another way around is introduced, and that is by using the English alphabet letter. So you need to keep in mind, instead of writing 10 in hexadecimal, you have to write A. Instead of writing 11, you have to write B. Instead of writing 12, you have to write C. Instead of writing 13, you have to write D. Instead of writing 14, you have to write E. And instead of writing 15, you have to write F. And that's just how it works. Okay. E is 14, F is 15. That's just how it works. Just keep that in mind. Okay. Once you see A, you assume it is 10. Once you see B, you assume it's 11. Like that, like that, like that. Okay. So that's it. That's what you need to know about that. So let's go back to the problem and solve it out. So right now we're having B, C, D. And we know that B is 11, for C is 12, and D is 13. So everything is in base 16. So we have to convert it to base 10. So right now what I'm going to do is to apply the process, the pattern that we used in the previous example. So first, we have to expand the digits that makes up the hexadecimal system by the base. So that's 11 times 16. Then I'm adding that to the product of the base with the next digit. So that's 12 times 16 plus 13 times 16. Okay, so right now I can assign the index starting from the right hand side all the way to the left hand side, and the index will be 0, 1, 2, 3. So at this point I can simplify the index. So 16 raised to the power of 3, that results in 4096. And I'm adding that to 4 times 16 squared, that results in 256. And I have 12 times 16 raised to the 1 is 16, and 13 times 16 raised to the power of 0 is 1. So 11 times 4096, that results in 45,056. And I'm adding that to 4 times 256, and that results in 1024. And finally, or second to the last, I have 12 times 16, and that is 192. Then I have the final one to be 13 times 1, which is 13. So to get my final result, what I'm going to do is just to add all these things together, and boom, I should have my final result. So 45,056 plus 1024 plus 192 plus 13, that should result in 46,285. And this is my final answer in this 10. Hopefully you find this interesting and comprehensive. Let's consider one more example for easy understanding. And I will recommend you pause the video and check these examples out yourself. So how can we convert 4B38 in base 16 all the way to number in base 10? Now, just like before, let's expand. So, okay, before that, let me just re-express. We know that B is the same thing as 11, and I have 3, I have 8, I have 16. So I'm converting that to number in base 10. So right now I can expand. So 4 times 16 plus 11 times 16 plus 3 times 16 plus 8 times 16. So the next step is the index. 0, 1, 2, 3. And the next step is to simplify. So 16 raised to the power of 3, we got that earlier to be equals to 4096. 4096. Then we are adding that to 16 raised to the power of 2. Earlier we got that to be 256 as well. So I'm multiplying that with 11. Then I have 3 times 16 because 16 raised to the power of 1 is 16. And 16 raised to the power of 0 is indeed equals to 1. So right now, I can just multiply everything together. So 4 times 4096, that results in 16,384. So I'm adding that to 11 times 256, and that should result in 2,816. So plus 3 times 16, that results in 48. And finally, 8 times 1 is 8. So let me add everything up to have my final answer. So 3 is 4, and I have 19,256 in this step. And this is my final answer to this problem as well. And this is how to easily and mentally convert numbers in hexadecimal system to numbers in Biston system. Hopefully you find this content helpful. If you haven't subscribed, like I said, do work to subscribe to my channel to help my content and channel grow more longer. Thanks for watching. See you guys in the next video. And here is your practice problem. Feel free to comment your results in the comment section below for review, and I'm going to respond if your solution is correct or not. So you consider converting this hexadecimal system to number base in Biston system. See you guys in the next video.